In this session, we'll start looking at doing the valuation of the options, finding out what should be the worth of the option, or evaluating the worth of the option and then concluding whether the option is overpriced in the market, or is it underpriced, or is it more aptly priced. So this is what we are typically looking at when we are doing the valuation process. And there are two major models which are heavily engaged to do the valuation of the options, and one of them is the binomial trees option. So this session I'll try to focus on using the binomial trees to typically perform the valuation of the option. So to start with, or probably as an agenda, I would like to look at first of all a one-step binomial tree model. Right, I'll tell you what we mean by a one-step binomial tree model, wherein I am looking at an important mechanism of evaluating the options using what we call as the no arbitrage argument. Using the principle of no arbitrage, I would like to find out the value of this particular option. Then I'll introduce you to another valuation mechanism for finding out the value of the binomial, or by using the binomial trees itself. Instead of no arbitrage argument, I'll try to find out the value of the option using the risk neutral valuation methodology. Even this also is using the binomial trees itself. I'll try to use the risk neutral valuation methodology and then try to find out the value of the option. These two initially I'll showcase it using a one-step binomial tree itself. Once a comfort comes on one-step binomial tree, then I talk about two-step binomial tree approach. What is the kind of difference we bring out compared to a one-step binomial tree approach into a two-step binomial tree approach? And these two kinds of scenarios I would be working out both for evaluating a call options price as well as for a put option itself. And even I would be talking about how would this tree be constructed or being used both for American options as well as European options. Even that would be considered as a part of our valuation exercise. Then I would like to bring in the concept associated with delta, which is more to do with the sensitivity of the option. So how do I really look at evaluating the sensitivity or the delta using the binomial tree approach? Then how do I really get into the volatility assessment? How do I really look at the volatility assessment using the binomial tree approach? And instead of, let's say, one step, two step, if the number of steps really increase drastically, how does it get translated, or how complex this binomial tree becomes, and is there any other mechanism to address this kind of an approach? Adjust this binomial trees is something which we would look at. And finally, I would also try to spend some time in terms of not just the options on stocks. Probably how would I look at an option on a stock index? How do I find out the valuation for that? Just a quick intro to all these. How do I find out the value of the options on currencies? How do I find out the value of options on futures? Though we'll spend more and more time on these things at a later stage, here I just want to give you a quick summary or introduction using the binomial trees. How do I really spend time in terms of understanding the values of each of these instruments? So with that as a base, let's get started with the one-step binomial tree approach to value the option on a stock. As I really said, binomial tree option is one of the two major models that is heavily used to find out the value of the option. The other one being a Black-Scholes approach, which I'll take up slightly at a later point. But the binomial tree approach is one of the major mechanisms today that is being used for valuation of the options. The prime assumption this model goes with is the stock price, whatever is coming at any point in time, it follows a random walk. So it can either go up or go down. So today if the stock price is S naught, after let's say 1 month, it can either go up to some SU or it can go down to SD. That's a major assumption that is drawing. There is some probability that it can go up by some percentage, right? Probably there could be a probability P that it will go up by some percentage. There could be a probability 1 minus P that it could go down by some percentage. That's one major assumption that it is going to have with. And let's say based on that, if I am taking currently, let me assume that the stock price today is some 100 bucks. Today the stock price is 100 bucks. I am assuming that let's say after 3 months it can either go up by 10% touching 110, or it can go down by 10% touching 90. And let's say in the market there is one 3-month expiry European call option that is available, probably let's say for 105 bucks in the market. The strike price is 105 that is available for me, which is going to expire in 3 months. Now in case the stock price really touches 110, because the strike price is 105, from a call option standpoint, the long call is going to exercise this particular option. So he is going to have a payoff of 5 bucks. Here he is going to have a payoff of 5 bucks. But in case the stock price comes out to this 90, then this option will not be exercised. It would be expired because it requires buying the stock at 105, which the long position will not do, which will result in expiring of the call option. So the value here, the payoff here is going to be 0. So these are the two possible movements of the stock price, and these are the possible payoffs that are coming from the option. And we are making another assumption here. When I am going with a no arbitrage argument, I am saying in case of a no arbitrage argument, I am making an assumption that the arbitrage opportunities do not exist. And under that, the arbitrage opportunities do not exist kind of an assumption, I am creating one portfolio. The portfolio consists of X number of shares plus one call. The portfolio typically consists of X number of shares and one call, and the X is something which I am more interested in finding out, but the combination is in such a way that after 3 months the value remains the same, whatever may be the share price going up or share price going down. Right? The portfolio is created in such a way that there is no uncertainty of the position at the end of 3 months. So it's as good as saying if the share price goes to 110, I have X shares. So X times 110. I have one call option. Whatever is the worth of the call option. On this day, the worth of the call option, let's say, is going to be 5. So the worth of the call option at this point, so X shares, and at the same time, if the stock price touches 90, the X times whatever is the stock price 90, and here I have one call option, and the call option will give me a benefit of 5. So these two, the subtraction between these two, because I will take a long stock, let's say I take one short call position, X shares and one short call position. So I'm going to have a benefit of 5. I'm going to have a loss of 5 because the buyer is going to typically exercise the option, which will give me a loss of 5. Whereas when the stock price goes to 90, my position value is 90 and the stock and the option will not be exercised, so there is no loss to me coming from the option. So if the stock price touches 110, my position is going to be 110x minus 5 if I am holding X shares, and if the stock price touches 90, my position value is going to be 90x. Now what we are saying is, irrespective of whether it touches this or touches this, my portfolio value should not be changing after 3 months, which means I could very well integrate it like this, making it 20x equal to 5 and x equal to 1 by 4. Means if I hold 0.25 shares of the stock and one short call position, this will definitely hedge my position after 3 months, irrespective of whatever happens to the stock price, whether it touches 110 or 90, my position is not going to be affected. Just let's see, if I am having 0.25 shares, so if it touches 110, my portfolio value at the end of 3 months is going to be 0.25 times 110, and my call option is having a worth of 5. So overall this is coming out to 110 by 4, which is working out to 27.5 minus 5, 22.5. And similarly, if the stock price goes to 90, the worth is becoming 0.25 times 90, which is also 22.5. So the worth of my portfolio is going to be the same 22.5 even if the stock price goes up or goes down. Right? Now, which means after 3 months, my portfolio is almost a zero risk kind of a portfolio. I know how much amount I am going to get. So I am going to get this 22.5. So I know how much I am going to get, which is 22.5, and it is assured in all the cases. So if it is assured without any kind of a risk, the return should be equal to the risk-free rate of return itself. So which means the present value of this 22.5 for me is 22.5 divided by e per rt, where r is the risk-free rate of return itself. So if I am assuming that the risk-free rate of return, let's say, is around 8%, it's as good as saying 22.5 divided by e to the power of r 8% into t, which is 1 by 4th year. So which is working out to 22.054. 22.054 happens to be the present value of setting up this particular portfolio. And let's say today I have to purchase this, or I have to get into this particular portfolio itself. So this is the benefit that I am going to get in case I am having one stock and one short call position. This is the kind of benefit which is worth as of today. Now, on the other side, I want to look at what is the cost to set up this portfolio. What is the cost to set up this portfolio? I have to buy one stock today. What is the purchase price for this stock? One share today is being sold at 100 bucks. But I require only 0.25 shares. I am purchasing only 0.25 shares. So the cost of setting up this stock is around 25 bucks today. 25 bucks is the cost of setting up, and at the same time, because I am selling a call option, I am going to get some call option price today. I am receiving some premium. So this is the cost of setting this up, and this should be equal to the benefit that I am going to generate out of this. So overall, making the worth of the call option to 25 minus 22.054, making it almost approximately 3 bucks. So the worth of this option as per this mechanism is going to be 3 bucks. Right? Because this is a riskless portfolio, because after 3 months the payoffs are going to be the same, the amounts are going to be the same. So this portfolio is more or less a riskless portfolio, and a riskless portfolio cannot give a return which is more than the risk-free rate of return. So the worth of this the worth of this option contract should be somewhere close to 2.95 bucks. 25 minus 22.05, working it to 2.95 bucks. Because if at all in the market it is priced more than 2.95, then the portfolio wise it is going to cost less than 22.05. If it is pricing more than 2.95, the portfolio would be worth less than 22.05. So which means the risk we are earning more than the risk-free rate, which cannot be possible. Arbitrage opportunities are going to come up. So we should the optimal price that is associated with this call option is going to be 2.95 bucks only. In general, probably instead of taking the numbers specifically, if I have to go with a similar kind of generalization, S naught being the current price, probably there is a chance that it can go to S naught into U percentage up, or it may touch S naught into D, which is the D percentage down. And so here what we are saying is whether it touches the S naught into U or S naught into D. So if at all the stock price currently is S naught, I am talking about it as up or down. And probably if I am assuming that F or probably CU call option, when the value of the call option or the payoff here, let's say is CU, the payoff here is, let's say, CD, right? If so, here I am talking about X number of shares and one call option, one short call. So now let's say the current stock price is S naught. So probably I would have invested X times S naught to purchase X shares. I would have invested X times S naught, and because I have sold a call option, today, whatever is the price that is whatever is the price that is associated with the call option, I'm going to get that. So today's amounts are going to be something like this, but I'm creating a portfolio in such a way that after 3 months or after whatever time period, the values are going to be the whether the stock price touches this or this, the portfolio's value is going to remain unchanged. So from that standpoint, what I'm typically taking is I'm creating a portfolio of X shares, assuming that the stock price has gone to S0U, where it has gone up, and because of the short position, the value, the short call, let's say if it is exercise, then typically it is coming out to CU is the down. Similarly, when the stock price goes to S0 into D, the value is becoming X S0 D minus CD in case even that is exercised also. So the value of the portfolio should be the same even if the stock price goes up or goes down, which means these two should be the same. That's the same thing which we have executed earlier just with the numbers. Now I am talking of without the numbers. So this is coming out like CU minus CD divided by S naught into U minus D. So S naught into U are probably if I'm saying U is a percentage up or percentage down, then it is typically coming out to be something like this. So we know that these many shares really need to be purchased, right? And if I am looking at what is the value of the portfolio at that point, I can take it as CU minus CD divided by S naught U minus S naught D. Those many shares are getting purchased minus CU. So overall, if I am looking at expansion, it is coming out as S naught U CU minus S naught U CD minus S naught U CU plus S naught D CU. So overall this is coming out, these two are getting off. Overall it is coming out as S naught DCU minus S naught UCD. So this is the worth of the portfolio that is coming out, right? And from here I should be able to make out what is the probability. So this is the worth of the portfolio that is coming out. S naught DCU minus S naught UCD. U percentage going up, otherwise it is talking of S naught into DCU minus UCD. This is the kind of a price that is typically coming out, and I can very well take the risk-free rate of return, because if this is the worth of the portfolio in any case, even here if I am trying out, X is coming out as CU minus CD by S naught U minus S naught D. Here also this is getting divided by S naught into U minus D. So overall it is coming out as DCU minus UCD divided by U minus D. Or probably without simplifying it, let me try to put it in this way. The worth of the portfolio was X times X number of shares taken S naught U minus CU. This we have equated it to X times S naught D minus CD. So from here we have arrived at X being equal to CU minus CD by S naught U minus S naught D. Fair enough, I can simplify it. But at the same time, if I am looking at the worth of the portfolio just in terms of X itself, the worth of the portfolio is X times S naught U minus CU, right? And this, because this would be the same irrespective of whatever happens to the stock price. If I try to find out the present value of it, this is the present value of the benefit or the present value of the worth of the portfolio. This should be equal to cost of setting up the portfolio. What is the cost of setting up the portfolio? I have X shares which I have purchased at S naught today, and I have set up, I have sold a call option which is giving me a kind of a premium which is equivalent to C. So at least with this, if I am trying to find out the value of C, the value of C for me is coming out as X times S naught, right? If I am looking at the value of C, it is coming out probably this. I would write it as e power into e power minus RT. So if I am taking C and so the simplification is coming out in such a way for C, it is coming out as X. So if I take it this to this side, and this becomes X S naught X times S naught U e power RT plus Cu e power minus RT. So based on this, I could have simplified it X S naught into 1 minus U e power minus RT plus Cu e power minus RT. I could simplify it like this. So now when I am taking out e power minus RT completely, e power minus RT, if I am taking out of this, and I am rearranging the terms in such a way that I could write this as some P times Cu plus 1 minus P times CD, which is the downside. So wherein the P is actually coming out in such a way like it is e power RT minus D by U minus D. Even that would get simplified to the same, which means I could really find out the probability of the price going up as e power RT minus D by U minus D. From this example, I can generalize it and I can find out that the probability of the price typically going up is working out to e power RT minus D by U minus D. But from an understanding, from a practical perspective, I can set up a portfolio in such a way that the value of the portfolio does not change on the expiration of the contract. So if the value in any case on the expiration the value is the same, it is like a risk neutral, or probably it's a risk free kind of a portfolio. So it should definitely generate a risk free kind of a return. So the present value, to obtain the present value, I'm trying to use the risk free rate itself. So that's how the numerical which used earlier was able to derive what should be the optimal cost associated with what should be the optimal price that should be associated with a call option. The same logic I can very well execute with respect to the put option as well, because the same 100, there is a chance that it can go to 110, there is a chance that it can go to 90. So let's say I'm talking about a put option, I'll talk about one long stock plus one long put. So I will create a position in such a way that I take a one long stock position and one long put position. So so X number of shares, not one. So if the stock price goes to 110, probably it is going out to be X times 110 is going to be the benefit. And if at all the option is put option is available for 105, what we are saying is in this case the put option will go worthless. So this is going to give me a payoff of 0. Whereas in this case the put option is going to give me a payoff of 15 because the stock price is 90 and I am long on the put. So I am going to get a benefit of 15 by exercising this put. So the premium is going to be X times 110 plus 15. Sorry, plus 0 in case the stock price touches 110, whereas in case it is touching 90, then the payoff or the benefit is going to be, the portfolio value is going to be X times 90 plus 15. Now this should be equal whatever happens to the portfolio, so that's where we say this plus 15, which is working out to 20x equal to 15, working out to x equal to 0.75 shares. So the worth of the portfolio is going to be 0.75 times 110. So in this case, the worth of the portfolio is 3/4 times 110, which I can work it out as 67.5. No, 27.5, right? 25, 330. So this is 82.5. So the worth of the portfolio is 82.5. The present value of it is going to be 82.5 divided by E per RT, which is going out to be 82.5 divided by E power R 8% into T, which is 0.25. So the present value is 80.86. Now I have to set up this portfolio today. So I have to purchase 0.75 shares at 100 bucks, and I have to purchase a put option also. There is an extra cost for purchasing a put option. So it is coming out like 75 plus P is equal to 80.86, and from where I can operate the worth of the put option being equal to 5.86 bucks. So we could very well operate even the worth of the put options, the worth of the call option using this kind of a model, which is more or less similar in approach. We can set up a portfolio always in such a way that after the on the expiry date of the option contract, the worth of the portfolio is in such a way that whatever may be the situation on that day, the return is going to be the same, the value of the portfolio is going to be the same. So simple reason wise, we are talking about two securities here. One one a stock, whatever is some units of the stock, and one call. So there one call or put, one option. So there are two securities and there are only two possible outcomes that we are considering. So it's always possible to set up a risk-free kind of a portfolio. So once I am able to set up a risk-free portfolio, I would be identifying what should be the number of shares that should be bought, and based on that I should be able to find out what should be the typical premium that is associated with the call option. That's the typical way we would be operating using a portfolio creation kind of a model, or no arbitrage portfolio kind of an kind of allocation. All right. Now the other way which we can typically execute the similar kind of valuation process is using the risk neutral valuation methodology. What we say in risk neutral is the same logic. Okay, it is 100, it can go to 110 or 90, and if I am talking about a call option, the expected payoff here is going to be $5. If say the strike price is 105, and the expected the payoff here is going to be 0. Now what we are saying is, I could very well find out the value of this particular portfolio, or I could, using the risk neutral valuation methodology, I will be first finding out the probability of an upward movement and the probability of a downward movement. I am using these two things. So in this case, the downward movement, I'll take it as a proportion of the price, which is 0.990 divided by 100. The upward movement also, I'll take it as the proportion of the original price, 1.1. So here I'll take U as 1.1, D I'll take as 0.9. Then the probability of upward movement, here we will use the formula e power RT minus D divided by U minus D. This is the probability of upward movement we would be talking of. So if the R is going to be 8%, I'll take it as e power 8% into 0.25 minus 0.9 divided by 1.1 minus 0.9. This is typically coming out. This is coming out as the risk. This is coming out as the probability of upward movement. The other way I could have found out, how did I get to this particular formula? Let me assume that there is a P chance that the stock is going to go up. So what is the expected value? P times S naught U. That's a upward price. So 1 minus P chance that it will go down. So this is going to be S naught D. Right? This will be the expected value of the portfolio after time T. Now assume that there is no risk that is involved, which means this should have become S naught into e power RT itself, going the risk neutral after T period. If it is S naught today, it should be equal to S naught into e power RT, because it's just a risk-free rate of return gain. Even when I am talking about the expected value, even there I am associating it to be the same, which means if I equate these two numbers, P times S naught U plus S naught D minus P times S naught D, this should be equal to S naught e power RT. So I can take out S naught across to simplify the scenario. So I'll take it as P times U minus D equal to e power RT minus D. So from here I got the value of the P as e power RT minus D by U minus D. So applying the same here, in this case I have got the probability of upward movement. Probability of upward movement is coming out as e power RT minus D. This entire thing I am dividing it by U minus D. 1.1 minus 0.9. This is giving me that there is a 60% chance that the price is going to go up. So from here I can find out the expected payoff associated with this 105 call. So expected payoff is coming out to P times the upward movement. So this is the P times the up when the stock price goes up, the portfolio the option is having a value of 5, and 1 minus P times when the stock price is going up, the option value is going to be 0. So the expected value at time t is going to be 3. So I can find out the present value by discounting it at the rate of 8% for 3 months. 8% for 3 months. So I'm definitely going to get the same 2.945, which is 2.95, which we have got even earlier when we have used the portfolio based kind of a mechanism as well. So what we are saying is, if at all I'm using the risk neutral kind of a valuation mechanism also, the price of the call option is going to be more or less similar. So this is the typical way we can use to typically evaluate the worth of the call option using a single binomial tree kind of an approach. The same logic, probably if I am putting it in a spreadsheet form, let's say we are talking about the current price being 100 bucks. Now here I require few information, the U, which is the upward movement. Let's say I'll take it as a 10% growth, so I'll take it as 1.1. D, which is a downward movement, let's say I'll take it as 0.9. So from there I'm trying to find out the probability of so the actual up prices. 100 times 1.1 is the up price, and 100 times the down moment, the down percentage is the down price. And if we are talking about the strike price as 105, then and this is a call option, so what we are simply saying is if this price is less than the market price, if the market price is greater, then probably the call would be exercise, and the difference would be between the call option and the strike price, but otherwise the value is going to be 0. So here we are saying that 5 is the payoff, and here it is 0, which is the payoff. And at the same time, now I would be finding out the probability of upward movement, assuming the D is the risk-free rate of return is 8%, and I am also taking the time to maturity is 0.25 years. From here I am able to find out the risk neutral probability, which is working out to e power RT minus D divided by U minus D resulting in the probability of going up. Probability of going down, I'll denote it as 1 minus P, which is working out to this much. And from here, expected value at time t is something, expected payoff at time t, I could simply get it as the probability of upward movement multiplied by the payoff of up plus probability of downward movement multiplied by payoff of down. So which is showing me that, which from where I will find out the present value, wherein I'll discount this with the e power RT, the risk neutral number itself. So this is how I'm trying to arrive at the value of the call option or the put option. Now when I have to talk about the put option, it's a straightforward. Only this number will change. If I have the same put option at 105, then all I am saying is the put option will be having a value if the stock price is lesser than the strike price. So if the strike price is lesser than the stock price, the value is going to be 0. Otherwise, the value is going to be the strike price minus whatever is the stock price. So with that as the base, so this is becoming 0. Then probably this is also becoming this. So from here again I can very well derive what is the probability that the value is going to go up, value is going to go down, and from there the same logic will give me the worth of the put option using the one period binomial tree kind of a model. Right, so this is how we can use the risk-free valuation model to typically find out the worth of the either the call option or the put option. And now we will slightly move on towards two-step binomial tree model. Instead of using the one-step one, we'll use the two-step binomial tree model because if we are only talking about a situation that the current price is 100, after 3 months it's going to be 110 or 90. We are talking about too long a durations, but in two step probably it's as good as saying, okay, we'll look at it for every 1.5 month. It could go either here or here, and in case this touches here after 1.5 month, after 1.5 month more it can touch here. So basically after 3 months the number of options that are possible, or the number of possibilities for the stock price, we are increasing the moment we are increasing the number of steps in the binomial tree. So more and more accuracy, more and more accuracy of the pricing of the option can come out if we are using more number of steps in the binomial tree compared to the one step one. That's one of the prime reasons we are looking at the two step, and probably slowly I'll look at even if it is an n step binomial tree kind of a model. Alright. So in case we have to go with the two step binomial tree model, which is more for extending the one step. Probably the way I would look at in the spreadsheet is like this. Okay, the current stock price is 100. When I'm looking at probably at the end of 3 months, the stock price up by 10%. Probably I would now like to break it down into two parts. So instead of treating 100 here and saying after 3 months it can become either 110 or 90, now I am trying to bring in a slightly different perspective by bringing in one intermediate layer. So all I am saying is, okay, after 1.5 month it can go either to 105 or 95, and from here again it can go, let's say, to 110.25, something like this, or it can come back. So if I'm talking about 5% up or 5% down, the same logic I could put for some percentage up, some percentage down, and probably create some such kind of a position which could very well result in trying to give me a slightly better enhanced version of the tree, right? Or probably I could talk about some different kinds of numbers at different points in time. So either I could put a 10% increase and a 10% decrease or something like that. So because here I talked about a 5% increase and again a 5% decrease, or probably a 5% decrease and a 5% increase. So this could be either on 95 there could be a 5% increase, it can go to something, and at same time it can come to this, and after that we'll talk about a call option. So probably here all I am looking at is, let's say, a 5% up. So I'm increasing it let's say by 5%. Okay, this is the 5% up, or it could go 5% down, which is 1 minus of 5%, so it can come to 95. The moment in case it touches 105 in the next period, again there could be a 5% up. So I'm talking about the price going to 110.25, or probably there could be a 5% down, which actually is going as 99.75, and probably another here also there could be a 5% down, which could be going as 90.25. Now here, what are the numbers that are changing? The time period in my case, still the option could be a half a year option itself. The option could still be expiring in quarter a year. The option could still be a 3 month call option. The risk free rate, I can still assume it to be 8% per year. The up movement this time, I'll take it as a periodic up movement. So which I would be taking as 105 divided by 100. So which is coming out to 1.05. Even the same logic will go for 110.25 divided by 1.105. Anywhere it is 1.05. The down movement also this time I'll take it as 95 divided by 100, and I'm talking about a strike price of 105 again in this example also. But this time when I look at the probability of up movement, I need e power rt, e power r. This time I wanted t is one single for each time period. So I'll take it as 1/8 of a year. E power rt minus d divided by u minus d. So the probability of going up at each of the is working out to 60.05%. And from there the probability of going down is getting operated as 1 minus up. And now here the game changes. When I am using a two-step binomial tree model, I'll try to evaluate the value of the option at each of the nodes. So probably I would look at this separately. From this node, these are the options, and I would like to look at this part separately. From this node, these, and after that I'll look at this separately. So basically I'm trying to split this into three one period tree models. This is one period binomial tree, this is one period binomial tree, and this is one period binomial tree. So we'll work from this layer. So we'll convert this two period binomial tree into many one period binomial trees and then evaluate them in the same way. So let's look at that aspect. So here, if I'm talking about a strike price of 105, I could very well say that if the market price is greater than the strike price, I'll take the difference between them as the payoff, correct? I'll take the difference between them as the payoff, otherwise I'll take it as 0. So here the payoff is coming out to 5.25, whereas here it is 0 and here also it is 0. Now using the risk neutral valuation methodology, I am finding out the expected value of the payoff at this particular node. What is the expected value of the payoff at this particular node? Probability of up move. There is a 60.05% chance that the option would be exercised, giving a 5.25 payoff, and 40%, 39.94% chance that it will not be. So I'll take the expected value of ST. So probably let me write it as expected value of ST expected value of S at node 1 at probably 1 and 2. So at 1 and 2, if I am looking at the expected value, up movement multiplied by up payoff plus down movement multiplied by down payoff. So obviously this is working out to 3.15. So I can take the present value at node 1, which is at 105. If I am taking it, it's nothing but this value. I'm discounting it by e power r t. I'll take it as 1 by 8. So this is working out to 3.12. So here the value is working out to 3.12. Now the same logic I'll find out for this tree. Expected value of S at 2 comma 3. So anyhow it's 0, but still to make our model compatible, up movement multiplied by up payoff plus down movement multiplied by down payoff. So it's 0, and probably I can talk about PV at node 1 comma 2. Probably at node 1 at 95 being the price. So I'll take the present value, this divided by e to the power of r t 1 by 8. So this is working out to 0. So this particular number for me is working out to 0. Now using 3.125 here, 0 here, I should be able to find another expected value. So expected value of S at node 1 comma 2, again at this layer. So up movement multiplied by up payoff plus down movement multiplied by down payoff. So 1.87, and from here I'll find out PV at node 0 working out to this number. I'm discounting by e power r t 1 by 8. So this is working out to 1.85. So this is the kind of a workout we are generally getting in to finally evaluate the price of our European call option using a two-step binomial tree model. So whatever is the number of steps that are involved in the binomial tree, the way we are trying to go ahead is start from the last and break that entire tree into so many one period binomial trees. Evaluate the value of each of the nodes by using the one period binomial tree approach, using the probability of up movements and the down movements, and work backwards and come until the node 0, and that is what will give us the present value of the call option or present value of the benefits in case the option is exercised, which should be the kind of a price that is associated with the call option. So as per the two-step model, this call option should be worth 1.85 bucks. Now the same logic, if I am going for a put option, only the payoffs should change. If the strike price is, if the stock price is lesser than the strike price, the strike price, the payoff should be 0, because put option would go worthless. Payoff should be 0, and if the stock price is more, if the stock price is less than the strike price, the option would be exercised. So the payoff is going to be strike price minus the stock price, else it is going to be 0. So here the value is coming out to be 0. Here the value is coming out to be 5.25, and here the value is coming out to be 14.75. Now using the same logic again, what we are seeing is at each of the nodes I am evaluating the value, and finally it has come out that the price of the put option with a strike price of 105, if I am assuming a 5% increase in the price for every 1.5 month, instead of talking about the 10% increase in the price at the end of 3 months, I have assumed that a 5% increase in the price at the end of 1.5 month, I am getting that the value of this put option is going to be 4.77 itself. So this is the way we can generally calculate the price of a European call option or a European put option. But in case I have to do the same thing in case of an American put option or American call. Okay. The last part is more or less the same when I'm going with American put. So in American, even an early exercise is possible. Okay, so what I generally do is I do the comparison here. Okay, we have found the present value here 2.07. What we'll typically do is, if at all the option got exercised at this place itself. So we are now, in case of American, we are talking about either continuing the option until the period 2 or exercising it in period 1 itself. So in case the option is exercised if the price goes to 105, what is going to happen if the price goes to 105? The option, so I'm trying to find out again, I'm trying to find out the same logic. What if the price goes to 105? So that's where we are saying if this price is less than, if the market price is less than the strike price, we are saying that the benefit is going to be to the extent of strike price minus the market price, otherwise it's going to be 0. So here the value is still 0, which means when I am trying to put this number, I'll not directly take it as it is. I'll take the maximum of either this value, which has come as the present value of the benefit if I go ahead for the next period, versus if I exercise it in the current period. Whichever is giving me a maximum, I'm going to go ahead with that. So probably here you will get a better clarity. Let's say if I am executing it at 95 itself, then the same logic if I am applying, if 95 is lesser than 105, if the stock price is lesser than the strike price, obviously the put option would be exercised. So the so the difference between the two is going to be the payoff. So in this case 10 is going to be the payoff, which means here I would have taken the maximum of this comma 10. So in case of American put, now what we are seeing is the payoff is going to be slightly higher, because if the price goes to 95, it makes a lot of sense for me to exercise the option at period 1 itself rather than continuing it or keeping it until period 2 or period 3. That is what is being notified here also. The present value, when I am continuing it until period 2, the present value is coming out only to 8.95, but when I am exercising it in period 1 itself, the present value is working out to 10. So that's where there could be a small change, and which is resulting in the present value of the benefits being 5.18. If I had the European option, we have got that the present value is somewhere around 4.8 something, but when I had gone for American, it came out to 5.19, which means an American put option is generally more high value compared to the European put option. We have discussed it even in our earlier scenarios, also on a conceptual standpoint, that the American put option, there is a possibility of early exercise and it is advised to go for an early exercise, whereas in case of American call, there is no benefit of going for early exercise. So even if I try out the same logic for American call, you will always find that the price or a premium that would be associated with an American call would be more or less the same for the European call and vice versa. Now, in this context, one more important aspect to typically look at is the concept of delta, which is a very important concept with respect to the pricing of derivatives, or probably what we call as the hedging of derivatives. And it also talks about the sensitivity of the option with respect to the stock price. Right? So typically whenever we talk about the delta, we talk about change in price of the option divided by change in the underlying stock price. This is what we call as delta. We have it's also similar to the number of shares that I need to hold to create a riskless portfolio for each call option shorted, or for each option held, either call option shorted or put option long. So this kind of a hedging, which balances the number of shares, either increasing or decreasing the number of shares to adjust the delta, is what is otherwise called as delta based hedging also. Delta hedging keeps our portfolio neutral to change in the stock prices. So the simple way, again, at each of the node I can work it out. Probably for a call or for a put, change in the option premium I can talk about at each of the layers, right? Change in the option premium. So in this case I can talk about this is the so I could, at each of the node I could very well compute the deltas here. Probably at this node, if I want to know the delta, it is nothing but change in the option premium divided by the change in the underlying stock price. So which is giving me that the delta here is minus 0.5. Here also I could talk about the change in option premium divided by the change in the stock price. Okay, this is almost minus 1. Here I can talk about the change in the option premium divided by the change in the stock price. So these are the measures of delta at each of the nodes. So this is what is the sensitivity. So in case the price is up by 1 rupee, the option premium is going to be, let's say, down by 79 paisa here, 50 paisa here, 1 rupee here. So in general what we see is, in case of call option, the delta is going to be positive, and in case of put option we observe that the delta is going to be negative itself. So this is one more important concept we need to be comfortable with when we are operating when we are operating it with the call options and put options using the binomial tree model. All right.